Hello everyone, I hope you all are doing very well. So we are here to talk to you today about the explosives, its definition, types, classification, effects, disadvantages, etc. So the basic part, that is definition and property part, shall be explained by Gururaj. Classification part will be explained by myself. I am Akshat Jani. Effects, advantages and disadvantages will be explained by Sushant. And the precautions that should be taken while storing the explosive as well as its applications in aviation sector shall be explained by Kodandaramayya. So let's go ahead.
Hello everyone, today we are going to discuss on explosives. So what are explosives? Explosives are the reactive substance that contains great amount of potential energy which are capable for explosion if released suddenly, usually accompanied with production of light, heat.
Properties of explosive. First property of explosive is density. The density of an explosive may be expressed in the terms of specific gravity. Specific gravity is a ratio of density of explosive to density of water under standard conditions. An explosive with a specific gravity less than 1 will not sink in water. With few exceptions, denser explosives give higher detonation velocity and pressure. Density is an important consideration when choosing an explosive. For difficult blasting condition or very fine fragmentation, a dense explosive is usually necessary. The density of an explosive is also important when working under wet conditions. Second property is detonation pressure. Detonation pressure is a function of detonation velocity and density of an explosive. Detonation pressure is more dependent on detonation velocity than specific gravity. The high detonation pressure is necessary when blasting hard, dense rock. In softer rock, a lower pressure is sufficient. The detonation pressure ranges from 10 to over 140 kilowatts. The third property is water resistance. An explosive water resistance is measure of its ability to withstand exposure to water without deteriorating or losing sensitivity. Higher density explosives have fair to excellent water resistance, whereas low density explosives have little or none. Fourth property is shelf life. Shelf life is the length of time that a commodity can be stored without becoming unfit for use. For explosives, shelf life of 1 year is required, although some explosives have shelf lives more than 2 years.
Hello everyone, I hope you are very clarified with the definition and properties of the explosives. So let's move ahead. Let's talk about the classification of explosives. Explosives are basically classified into two types: low explosives and high explosives. Some of the examples of low explosives are gunpowder, smokeless powder, which is also known as nitrocellulose. Examples of high explosives is further subcategorized into two further types: primary high explosive and secondary high explosive. Some of the examples of primary high explosives are lead azide, mercury fulminate, tetrazine, etc. And secondary explosive can be further subcategorized as single compound, binary, dynamites, and plastics. So we'll be looking one by one. We'll be going into deep. So let's start with the low explosives. What is the basic definition of low explosives? The decomposition rate of this explosive is very slow. So this explosive do not actually explodes, but it actually burns and it releases some of the gases which actually results in explosion. So some of the examples, as I said, gunpowder. Gunpowder is made up of 75% of potassium nitrate, 15% of charcoal and 5% of sulfur, and it is made by the mixture of all these three. Gunpowder, the basic application is in firearms, in fireworks, to cause special effects in casting of television and movies, in refilling the cartridges of bullets, etc. Smokeless powder, it's made by the reaction of cellulose in presence of nitric acid and sulfuric acid. So it is further treated with the mixture of ether and alcohol. Nitrocellulose, since it's not much intensified, the applications of nitrocellulose are not that much as compared to that of the gunpowder. Coming back to high explosives, what is high explosive? As we can say that the decomposition rate of high explosive is very high. So it is termed as high explosive. The intensity of this explosive is very high. we'll go to primary high explosive. They are very sensitive to mechanical shock, friction, and heat. We can, in simple words, we can say that the primary explosive is used to trigger an explosion. Secondary explosive is very insensitive to mechanical shock, heat, or friction, and it is used as a base explosive. So primary explosive is basically used to initiate an explosion, and secondary explosive is basically used to cause an explosion. Examples of primary explosive will go one by one in detail. Lead azide. Lead azide is made when 2 moles of sodium azide is treated with lead acetate. It is basically used as detonator. Its color varies from white to buff. One other example is tetrazine. It's very highly explosive substance. Its burning rate is very high. It is also non-toxic, and it is actually used in shell firing and also as detonator. One other example of primary explosive is mercury fulminate. And coming back to secondary explosives, they are further subcategorized as I said, binary explosive, plastic, dynamites, and single compound explosive. We'll go one by one. Binary explosive. Binary explosive, any explosive in combination with trinitrotoluene, that is TNT, is known as binary explosive. Substances like ammonium nitrate are used to prepare the binary explosive. Plastics. The combination of high explosives with glass or wax, which can be molded into any shape, is known as plastic explosive. Single compound explosive, as the name suggests, obviously only one compound is present in this explosive. The example is ammonium nitrate, which is very cheap, stable, which is non-toxic, which is used in the preparation of other binary explosives and also in high explosives. Other example is RDX, which is also known as cyclonite. How it is made? It is made by when hexamethylene tetraamine is reacted in the presence of nitric acid. RDX was used long back in World War II by many of the nations to cause the destructive effects, typically as explosive. It is also used in one of the first plastic explosive. Trinitrotoluene is also one good example of single compound explosive. Trinitrotoluene is prepared by the nitration of simple toluene in the presence of fuming sulfuric acid. Trinitrotoluene is also used in shell firing, and it also causes very high destructive effects and explosion. The last subcategory of secondary explosive is dynamites. Dynamites, the decomposition rate of dynamite is very high, its burning capacity is very high, and the intensity of explosion that it can take takes place with the help of dynamite is also very high. It burns very rapidly when ignited or gets triggered, and it produces a vast amount of gases which can produce further explosion or any heating effects. So guys, I guess you are very clarified with the classification of explosive. Let's move further to the precautions and effects. Thank you.
Explosion. It has high intensity product, loading, high density, energy balance harmony with most of the rocks. The disadvantages of explosion is high nitrogen oxides, temperature, friction and shock sensitive, dangerous in production, constant high explosion like nitro cycle. We are talking about effects of explosion. The first one is blast pressure. There is negative and positive effect happening. Second one is thermal effect. It is measured by the length of the burn and intensity. Intensity is given by the rapid expansion of gases. Third one is fragmentation effect. Blast breaks the around explosion change into pieces.
So far we have seen about the different types of explosions and mechanism of it. So let us now discuss the precautions and explosion safety. Explosion safety originated as a formal program in the United States in the aftermath of World War I, when several ammunition storage areas were destroyed in a series of mishaps. The most serious occurred at Picatinny Aerosol Ammunition Storage Depot, New Jersey in July 1926, when an electrical storm led to fires and that caused explosions and widespread destruction. The severe property damage and 19 fatalities led Congress to empower a board of Army and Navy officials to investigate the Picatinny aerosol disaster and determine if similar conditions existed at other ammunition depots. The board reported in its findings that this mishap could reoccur, prompting Congress to establish a permanent board of colonels to develop explosives safety standards and ensure compliance beginning in 1928. This organization evolved in the Department of Defense Explosion Safety Board and is chartered in Title 10 of the US Code. The author's Defense Explosive Safety Regulation, which establishes the explosion safety standard for the Department of Defense, and also evaluates scientific data which may adjust those standards, reviews and approves all explosions site plans for new construction, and conducts worldwide visits to locations containing US title munitions. And the cardinal principle of explosion safety is expose the minimum number of people for the minimum time to the minimum amount of explosives. There are 5 classification types in they are categorized under 1, 2, 3, 4 and 5 magazines. And explosions containers must not be placed directly against an interior wall for ventilation reasons. Explosions containers must be stored so that identifying marks are visible and easy to read. Metal containers must not be unpacked or repacked inside the magazine or within 50 feet of magazine. Tools for opening and closing containers must be non-sparking and may not be stored in magazines. Smoking, matches, open flames and spark-producing devices are not permitted in indoor magazine or within 50 feet of any outdoor magazine. Recent events like in aviation sector, recent events have highlighted the threat posed by terrorist bombings. So to address these evolving security concerns, the FAA identified the need to have an improved capability to assess the effects of explosions against civil aviation facilities and their occupants. For many engineers and security specialists, the need to assess the risks to building from explosions represents a new and often imposing requirement. However, by analyzing the relationships between blast, structural response and the response of exposed individuals, it is often possible to reduce risks to more acceptable levels. The paper discusses blast effects, explosion effects analysis software which was developed by the FAA by TRW to meet the needs of security and engineering professionals concerned about the threat of explosions. Blast effects allows analysts to quickly and efficiently create a representation of the structure. They are concerned about placed individuals in the faculty and realistic locations and specific like explosion devices of concern and estimate the effects of such devices in terms